Today we'll be talking about Overleaf and Latex. You've probably heard these two words being thrown around a lot. And so it's time that you all know what it means and why it's very important to astronomers. Okay, so what is Overleaf? And when I had to answer this question, I realized, let's just look at what Wikipedia has to say. So as it's given here, Overleaf is a collaborative cloud-based LaTeX editor used for writing, editing, and publishing scientific documents. It partners with a wide range of scientific publishers to provide official journal LaTeX templates and direct submission links. So if you notice, I have underlined a bunch of words over here because those are the most important keywords to define Overleaf. So Overleaf is basically like Google Docs, except it's not in a regular word processing format. It's in this thing called LaTeX. And it is very important because it makes writing scientific papers so much easier because it gives you a wide array of templates for journal articles or your research reports or for resumes, things like that. And also, if you had to submit these articles somewhere to a recognized journal, they usually have direct submission links, which makes the process so much smoother than actually having to fill a physical form and then uploading everything. So I mentioned Overleaf is like Google Docs and LaTeX. So the next question you would have in mind is, what is LaTeX? It's basically it is a software. It's not exactly a traditional word processor. You have to use plain text following a certain syntax, so like HTML or CSS. And the best part of LaTeX is it produces what you tell it to produce. You put in text, images, you format the text, you format the images, you put in other features, you tell it exactly where to place what, and it does that for you. So I've mentioned here that you use plain text following a certain syntax like a markup language. A markup language is like HTML, where you enclose content in tags. So you would have tags telling that, oh, this is the document part, this is the actual part of the document. Or tags to show like this text is in bold, or this text is italicized, or this text has to be aligned a certain way, or this image has to belong on this part of the page. So unlike in a word processor where you simply type, drag, drop, click around, in LaTeX you literally type it and tell the software what to do and how exactly you want your finished document to look like. There are pros and cons to using LaTeX, which you should know before jumping into this. One of the biggest advantages for me, and I'm sure everyone here will agree to this, equations and inline symbols look great in the typeset results. So typically, if you want to type equations in Word or in Google Docs or in Pages on Apple, you have to go to the insert form. You have to go and insert these equations or the inline symbols from a different keyboard. You have to know what the options are. There are keyboard shortcuts, but it is a little cumbersome. You can't just directly type it in. But with LaTeX, using the right commands, which I will show you shortly, you can actually just simply type it in, and it looks like it's just a part of your regular text and not something that you've added on top of it. In Word and in Pages, I know when you add equations, they look a little different, and they look like images. You can't simply just copy and paste them like you do with text, but in LaTeX you can. That's a big advantage. Another advantage is once you type up your code or your template for a certain document, you can always reuse it. Maybe it can be for an entire document, maybe it can be just for writing equations or printing tables, but you can keep on reusing it because especially on Overleaf, it allows you to save something as a style file, and you can implement that across all the documents you write. It is possible to do this on Pages and on Word as well, but that's more of a page styling thing rather than a text styling or text formatting thing. In LaTeX, it allows you to format text and save that as a template. And last but not the least, well, there are several more pros. These are the three most important ones. But the third one is it's an easier option to cross-reference and for bibliography. So when you're citing things, either in your image captions or in your main text, you can just do /cite and a tag by which and it calls up whatever resource or article or website that you're supposed to be citing there. How referencing works, I won't be talking about in this in this little tutorial, but I have some resources linked at the end, and that should give you further understanding. Basically, you can create a separate document that lists all your articles and papers that you're referencing, and then you can call that in later in your main document. So LaTeX sounds great. It has all these pros, but it also has its own disadvantage. One, as you may have figured out by now, it works very differently from a conventional word processing software. So you have to do a bunch of work in the background to actually learn how to use it. It takes a little bit of time. You need to be patient. It is a very steep learning curve. So learning how to use LaTeX is time consuming and may not be the best option if you're going to use it just once in your life. But since you're all here to be astronomers or something related, it is worth your time. Two, tables are not easy to design. So in a word processing software or in like in MS Word or Pages or Google Docs, you can just go insert table and define how many rows and columns you want, and then you can just right click, add more, or use your shortcuts or whatever. But here you have to use separate commands for inserting a new row. You need to have formatting commands to show where on the page your table should go. It's a little harder. It's a little cumbersome to manage. You need to define separate formatting options to wrap text, to keep, if you want to maintain your cells in a certain length. It does not come very naturally. It's not very intuitive always. And sometimes it's kind of like Python, where you have to import packages to use certain features. So sometimes it can be frustrating to find the right packages and to even get the basic things right. Sometimes you're missing a package which you didn't realize you were missing. Or maybe you have the package, but you haven't called the right formatting options from it. And you're not using it right. So all these things make LaTeX a little cumbersome to use. But if you take the time and if you learn it and you have the right resources at hand, it's actually worth it. So that's why. And so now let's say you're going to use LaTeX. Overleaf is not the only text editor. LaTeX and text, they're basically the same thing. Text is basically how it was introduced. LaTeX is like text version 2.0, if you may. There are subtle differences between the two, but I'm not going to get into that now. So there are text editors that you can easily download on your desktop and you can work on it offline. Overleaf is an online option. But why would you want to use Overleaf? Because Overleaf is a much, much simpler LaTeX editor option, in short. It not only allows you to write things so in a regular text editor, you have to write everything like you're writing an HTML document, following that syntax that I told you about. But in Overleaf, if you don't know the LaTeX syntax, you can actually write things as a rich text editor, like as though you're formatting things on Word or Google Docs. And everything still works the same, even if you don't know the LaTeX syntax. You will still see this, and just as in a regular text editor, you will still see the types of document that's being created as you edit your main document or you type it up. But the types of document, I mean like the PDF output or however you want to save the output as. So now how to use Overleaf? It's very simple. You go to overleaf.com and if you already have an account, you just straight away log in. If not, you can start up with an account. You can register using your email address or using Google or using your ORCID ID. It's something people typically have when they're writing papers. It's kind of like, how do I describe it? It's kind of like your ID number, but for a world of scientific publishing. It's this unique number that's assigned to you as an author. So when people click that number on papers, they get to access and see everything and anything you've published. And Overleaf can also be connected to your GitHub. So especially if you're using Overleaf to write documentation for code or writing papers or research reports based on the code that you have on GitHub, I think it's a very useful tool. And also some institutions have a premium Overleaf service. So if your institution does, you should find that out. And because premium Overleaf has so many more features, which makes it wonderful. So once you log in, this is what your Overleaf screen looks like. For those of you who used it before, please be aware Overleaf has come recently with some more updates. So it looks a little different than it did maybe 2 months ago. So this was a screenshot of LaTeX that I took quite some time ago. This is what it looks like. And you basically click on new project if you want to create a new project. And you have all these bunch of options. You can create a blank project. You can, as I said, if you have something on GitHub, you can import it here. Like usually when you host code on GitHub, you have to create a markdown document. And so you can maybe import that and format it and make it look better on Overleaf. Or you could use anything from these bunch of templates they give. I cannot stress this enough when I say templates are basically your best friend in Overleaf. This option right here, it has a gallery of templates you could use. These are created for free use. They're created by people who use Overleaf all around the world. It can be, you have publishers, scientific journal publishers who have templates on here. And you also have people who created templates for things like a science presentation, a conference poster, maybe how to write a final exam, or maybe you want to write your CV, or maybe you want to write your thesis for college. You have templates for all of that. And so you should always use these templates, or else if you're interested in creating a brand new template of your own, feel free to do that. But for me, I always straight away go to these templates, or you could see I've created a bunch of files, so I just open one of those files and use that as a template for my next file. So once you create a new document, this is what it kind of looks like. This is a simple simple document that I've created just to highlight what the features of an Overleaf window are. So this is the layout of your Overleaf window. So I'm just going to go one by one through the main features here. So over here, so on the left-hand side, you have this panel that has menu-like options. One important one at the bottom is the file outline. So it basically gives you the structure of the document based on whatever sections and subsection headings you've used. So you can see in my main document screen. So this is, by the way, the format of how a LaTeX document looks like, the syntax that I told you about. I'll be exploring this further very soon. So you can see I have a section title saying introduction, another section saying pros and cons, another subsection saying pros. So it just gives that as a file outline just for a person to have a quick view of what your file looks like. And a lot of times, documents created here, when you download it as a PDF and you open it with the PDF viewer, you will see the same file outline if you choose to see it in the PDF viewer. The next important part is creating and uploading a new file to create and upload files and to manage these files. So now an Overleaf document is not necessarily just one main text file. Main.txt is basically where you write it's a conventional name for the main text document where you write up all your information that you want to be printed. But you also have other supporting files. You could have a couple of you could have all the images that you need to put in your LaTeX document. You could have style files, so markdown.sty. Sty is a style file, which basically is a pre-created document that tells what formatting you need to do for this document. Then refs.bib. .bib is basically for bibliography. I don't really use it on this document, but it's very handy. And on the top, you can see you have options to create or upload new files or folders or to delete them. And you can upload files either from your computer or you can just pull them in from other Overleaf files. Sort of like how in Google Docs, where you can either upload things from your computer or upload things from your drive. The next thing over here, I've shown you before, source versus rich text. You can either type it like this, as I've shown here, or you can switch to the rich text format if that's more comfortable. Although I would suggest learning this format because it's so much easier and you feel like you're in control. Now, this symbol right here is, you could actually click and choose special symbols instead of directly typing them in. So for example, if you want to print the symbol for alpha, you have to do $, $/alpha, like spell it out, and then $, again. But if you don't want to do that, you can directly insert it from there. But I've started because it's a premium feature. So if you're a free user, like most of us, you have to type it in. Then review right here tracks edits. Now that is also a premium feature. So that basically works as tracking or reviewing changes like you have in Google Docs or in Microsoft Word. And it's very useful if you're working with a collaborator. Share lets you to share with a co-author. So in a free version, you can share with one more person. If you have a premium account, you can share with multiple co-authors, and it's very helpful when you're writing an article to be published, because usually you would be collaborating with multiple people on a project. And submit here is usually for journal submission. If you're using a template for a journal, let's say you're using an AppJ template, you would directly have a submission link for AAS. So that it's and it is a little more fast track than actually having to upload your document, because even for the reviewers, it's easier to manage this. History here shows you the changes you've made in the document, you or your collaborators have made in the document over the last 24 hours. If you want all of the history ever since the document was made, again, you'll need a premium account. Now, this is a new option, layout, that manages the layout of this window. This is the standard layout, but you could also manually adjust it by, like, you can see there's a border separating the PDF version and the text version. So you can just drag around, click and drag to manually adjust the layout, or else you could go to layout options, menu right here for some preset options. Chat is to chat with your co-authors, just like you do in Google Docs. And this little sign right here is to download the PDF version of what you've just printed. The little text paper right there, that symbol is to switch between your output file and LaTeX log. So right here on the right-hand side is the output file or the typeset file. But if you have any problems that is preventing you from getting an output, you may want to switch to the LaTeX log for debugging. So it just works like Python or any programming language where the IDE or the code developing environment would give you an option to debug your code. That is your debugger in LaTeX. And then recompile, it basically is to compile your changes. You could either have that happen automatically, so each time you make a change, it's synchronously updating your PDF document. Now, that could be a little memory consuming and a little cumbersome, especially if there are a lot of people who are on a LaTeX server at a given time. Or you could compile manually, that you make a bunch of changes and then compile it. Then you compile it after a while. And then you have an option to compile it with or without images. Again, depending on the bandwidth you're on, you want to make a choice. Now, this is the main thing. I skipped the menu option because it has a lot, and this is basically what menu looks like. I just made it 3 panes, but it's actually a single pane that is scrollable, but I just made it for you to just view it better. So in the menu, you can choose to download your files, you could do a main account, you could sync it with your GitHub, your Dropbox, and all of that. You could change how you view the document. So this is how its standard looks. This is its standard appearance, but you could have it have a dark theme. You could change the font. You could change the font of the typeset of the code document. You could change how things look like. You also have a help option if you get stuck with all of this. So these are the main features of LaTeX and how, not LaTeX, of Overleaf, and how to navigate yourself around a document. Now, going into the basic LaTeX template that I created. So this on the left is what I typed. On the right is the output, what I get from whatever I typed. Now to break it down as to what is in here. Every LaTeX document has two main parts, a preamble and the document environment. Now the preamble is basically that part like in Python where you import all your packages. You define the type of document you want to create. So document class article is usually the standard, but you have other document classes. Or if you're using a journal template, you want to call that template. For that, you would have an additional file, but that's another thing, so I'm not going to cover that for now. You're going to define the document type, and you're going to import all the packages that you need by calling /use package. And then after the preamble, you have your document environment. Basically, it is the actual content of your document that needs to be displayed, including all the markup type commands. So, your bold, italics, underline, inserting images, inserting equations and tables, that sort of thing. Now, the document also contains your other pages like your bibliography, index, glossary. Those things, they need not be included physically in the document environment. You can create it in other text files, and within the document environment, you can call it. I won't be covering that now because that's a little too advanced for this session, but you have resources where you can look it up. And in the preamble, there are these two things that I want to point you to. The package, which is basically what you call. So let's say when you're doing import numpy, numpy is your package, and that's what it's called, package in LaTeX as well. But before certain packages, you see something in square brackets. Now, those are keyword arguments that override default settings. Some packages are set in a certain way, but then, so it's kind of like functions in Python. If you call a function, you will want to define some keyword arguments. Some functions have default arguments. So if you just call the function without those arguments, it's going to behave as it's set to do in default. But you could override the default settings by using these keyword arguments. Now, this was the main document. If you see towards your bottom left, you can see something I wrote as begin figure and end figure. Now, this is creating your figure and figure environment. So right here, to create a figure or a figure environment, you need your image package. Use package GraphicX. GraphicX is your go-to image package. It pretty much works like Pylab or Matplotlib in Python. Now, you want to create a figure, so you can either insert a figure with or without the environment. We always want to do it with the environment because it comes with additional features. So begin and end creates a new environment. It can be a new environment for figures, a new environment for tables, a new environment for lists, a new environment for equations, etc. Here, we define begin figure and end figures, so we're creating a new environment for a figure. Include graphics is basically what inserts the image. So include graphics and the option curly brackets, that calls your image. Now, how does it know which image I'm talking about? If you saw earlier, a couple slides back, in the file on your left-hand side pane, you could upload your image from wherever it's saved. And when you're calling it, Overleaf knows that you're calling an image from this. And whenever you're inserting an image or something external, it always has to be in the same Overleaf file that you're writing your main document in. So include graphics actually includes the image. And if you want to, change its size or crop it, you would want to insert the keyword arguments in square brackets right after you write include graphics. Caption here gives you the figure caption, and it automatically numbers the figure caption for you. So it is so easy to manage. Label here is kind of like a tag. So when you're writing the document, for instance, I want to say figure 1 shows the logo of LaTeX. So instead of writing figure 1, I can always call this image by saying /ref and the /ref and the tag. So here I call it as fig latex fig. So I can call it as /ref fig latex fig, and it automatically puts in the words figure 1 for me. And if you enable it, that actually becomes a clickable link, which lets you jump directly to that image. Now that's all about figures. Now for math, which is the most interesting and easy part of LaTeX, you could either have math inline or you could create a separate equation line. So if you're creating an inline math option, I just put this here. This is literally what you type. You can type whatever words you want, and whatever math you require, you put it between these two $signs. Or if you want to create a separate equation, you create an equation environment by saying begin equation, end equation, and within that you enclose everything you want, and this time you don't need your $signs. An equation environment, just like an image environment, it gives a little number, the equation number there, and you can also add label here, so you can give your equation a name. So let's say, I forgot what this equation was for. It was I just remember it was from some aspect of statistics, astronomy statistics, I think the T factor or something like that. So I can call it label T, I can put the label as T factor and then ref T factor, and it will give me the equation number 32. So as I said, $sign is used for equations, mathematical, and other special symbols. Now, if you see I've written things like an underscore and /frac or a caret sign, now those are for placement. An underscore means subscript, a caret sign means superscript, which is pretty standard across all text editors. And to insert things like the square root symbol or make things look like an up and down fraction, I insert these words. And this equation number I set is inserted by the equation environment. Now for table. Again, for a table, you still need to create a table environment. But if you can see that it has something called begin table and begin tabular. Now, begin tabular is something that is the thing that actually creates a table. Begin table, it lets you put in the other supporting information you need for the table. So if you compare it to our image thing, begin tabular and end tabular is basically the include graphics part of it. Begin table and end table is basically where I put in my captions and labels, etc. And the two things that you need to know here, or three things you need to know here, are how to insert the new row and how to manage the number of columns. To manage the number of columns, we define this little curly bracket thing right after begin tabular. You basically put in these bunch of letters to define how many columns you want, but these letters determine either the size of your column or the alignment. So I put in CCC, which means I want 3 columns where everything is center aligned. If I put LLL, I would have 3 columns with everything left aligned. And if I want lines between my columns, I put in these vertical lines here. If I don't want borders between each column, I simply put CCC and it works out. Or if I just want a border on the exterior of the table, I put line, CCC, line. The double slash here is to insert a new line. It works not only for tables, but also works in the main document. And / H line inserts a horizontal line. Again, it works everywhere and not just in the table. So that's what I have. These are some useful LaTeX resources compiled by NYU Libraries and Harvard Library. This is uploaded as a PDF on the GitHub, so you'll be able to, these are clickable links. And for Overleaf resources, the best one is to go to Overleaf's official tutorials, because they break down everything so beautifully and enables you to use Overleaf very efficiently. And as for your assignment, it's very simple. Pick up, and so there won't be a solution key because obviously it's going to differ from person to person, but obviously feel free to ask any of us on Piazza. You basically pick up a topic in astronomy of your choice, and using the AppJ template in Overleaf, you now know how to search for templates. You write a 2-page paper on the topic and you create separate sections on it. You saw how I did that. You just do section, you can create a section, or you can create subsections if you want those. So you create a topic paper with these few sections, and just to get a practice with it, you can include a few images, few occasions, and at least one table. And an extra thing that I did not cover here is to type in references or using a .zip file. The reason I didn't cover this here is so that to give you a motivation to actually go over these resources.